Okay. So that question was an application also somehow on the first principle. So we're looking at applications. Of differentiation. In form of examples, like 1. Find dy dx using first principle given that y is equal to the cube root of x. Solution. Here, we know that dy dx is going to be the limit as h goes to 0 of the cube root of x plus h minus the cube root of x, everything over h. Okay. Now, here you know that the target always is to get rid of the, is to extract the h from the square root there. In this case, we are saying from the cube root there. We need to extract so that it can help us cancel this h that is down here. So when multiplying, when looking for numbers to use to multiply here, you look for the numbers that are going to get rid of the cube root on x plus h and also x. So you think of something like this. If I had a to the power 1 over 3 minus b to the power 1 over 3, if I multiply this, if you multiply this by a 1 over 3 plus b 1 over 3, as many of you were doing, you would notice that when you multiply, you have a to the power 2 over 3. That is still the cube root. You still have the cube root squared. So you have issues there. So what you do is you say, okay, so I need to multiply by a number here so that when I multiply by a to the power number 3, I must get 1 here. Meaning you get 1 minus 1 over 3. So you have 3 down, 3 minus 1, giving us 2 over 3. So a power of a that is needed should be 2 over 3. So we place 2 over 3 here. So we know that even there we must have 2 over 3. Now let's see if nothing will give us challenges in between. So what you do now is this. Okay, let's see. A, you are sure here will remain with a, because when you add 1 over 3 plus 2 over 3, we get 3 over 3, which is 1, plus a 1 over 3, b 2 over 3, minus b 1 over 3, a 2 over 3 minus b. But again, we can see that this and this are not cancelling. So it means that there's a need for another term in between our right term here for us to be able to put this together. So let's see. We go back to it. Say, okay, we just need to get rid of these terms in between here. So let's combine our two terms on the left as we bring this thing on the right. So we combine, we get a to the power 1 over 3 and b to the power 1 over 3, and then bring back the b to the power 1 over 3. In other words, you put a product of a and b to the power 1 over 3. So now we are sure that when we multiply, everything will be cancelled. So we are doing the same here. We'll come here and multiply this by x plus h to the power 2 over 3 plus x plus h cube root, and then x cube root as x, and this is supposed to be 2, power 2 over 3. Whatever you do in the numerator, you do in the denominator. X plus h 2 over 3 plus x plus h 1 over 3 x 1 over 3 plus x 2 over 3. We have the limit as h goes to 0 of what? Of this guy here multiplied by this one here will remain with only x plus h. This guy multiplied by this guy will have plus x plus h to the power 2 over 3 multiplied by x to the power 1 over 3. This guy here multiplied by this guy here will have plus x plus h 1 over 3 x 2 over 3 minus x plus h 2 over 3, this one multiplied by this one, x 1 over 3, and then this guy again multiplied by this one will have minus x 2 over 3 x plus h 1 over 3, and then now this guy multiplied by this one here, we just have minus x. So we'll get back to the denominator. Let's deal with the numerator now. So you can see that this guy cancels with this guy, and this guy cancels with this guy. So this x cancels with that x. So we remain with h, so that when we bring the denominator, we'll have h x plus h 2 over 3 plus x plus h 1 over 3 x 1 over 3 plus x 2 over 3. And then now we can see that this h and this h will cancel, so that where there is, so on top we have 1, down where there is h here we bring 0, so we have x to the power 2 over 3 plus, here we'll just have x multiplied by this x, so we have x to the power 1 over 3 multiplied by x to the power 1 over 3, which is the same as adding the powers, giving us x 2 over 3 plus, this is already x 2 over 3. This is the same as 1 over, how many are they? There are 3 x 2 over 3, which is what you must find using power rule. We get that.
So isn't there a simpler way to work this out?
Sir, that was another method.
But for power rule,
This
I'm finding that my using first principle, mulempanga J dot doing. I'm not even
so,
feeling on para.
So can you
so
repeat on the part where you are doing the multiplication, where you have a to the power 1 over 3? What did you do there?
So when you have a to the power number 3, you're just trying to, because remember we said that if I have a, m plus n, it's the same as a, m, a, n. So if you have a to the power number 3, a to the power number 3, multiplied by a to the power 2 over 3, it's the same as having a to the power number 3 plus 2 over 3. So the denominator there for the power is 3. So the numerator you have 1 plus 2, which is 3. So you have 3 over 3, giving us only a.
Oh, okay, I've understood now.
Sir,
Hello.
so if you were just to use like power rule, then they have told you first use first principle, but you just write the formula and then go direct to the answer, sir. Is it?
It's wrong.
Kosa ma AI nze nakuyachoka naona chebibanda.
Mm. Okay, so now let's move now to tangent
So please let me
and
take a screenshot.
tangent and normal lines.
All right, thank you.
Okay, tangent and normal lines. The tangent line to any curve is the line y is equal to mx plus c. This equation is the same equation for the normal line, for n line, whether you call it tangent or normal. So to n line, that's how the line looks like. Or y minus y1 is equal to m x minus x1. Same thing. Any of these two lines, any of these two equations will land us to the very thing that is called a line. The question here is, how then are you going to be getting m? Because we know if you are given a straight line and we put a point there, 4,7, another one here, 2,1, then they say find the equation of this line. What we do is we just say, okay, m of this line, the gradient, is going to be y2 minus y1 over x2 minus x1, where you name them. So you say 7 minus 1 for the y's, and then 4 minus 2 for the x's. So you have 6 over 2, which is equal to 3. So you'd call this your gradient, and then go to n of the equations. If you go to this one, you will say 3x plus c, because you have found the m. Now, how do you then find the c? You pick either this point or that point. If you pick this point, the value of y in this point is 1, the value of x is 2, and then plus c. So you use it to solve for c by taking this to the other side. So you have 1 minus 6, which is equal to negative 5. You come back to the equation and say, so this equation is y is equal to 3x minus 5. Okay? That's how you find the equation. So that if they ask you to find the equation of a normal line to this given line, you know that they are asking you to find the equation of a line that cuts this line in between, and when they meet, they form 90. Okay? Now, to find the equation of this line here, you don't need to look for points again. What you do is you use a relationship that the gradient of this line, if we call it mt, and the gradient of this line, we call this one mn, this one mt. You know that when you multiply the gradients, we get -1. Okay, this is a formula that you must know. So you use it always when you're asked to find the normal line. So since we have the mt, you have 3 mn is equal to -1 divided by 3 divided by 3. So you have mn is equal to -1 over 3. So if you're looking for this, so this one is a tangent equation. This one is a tangent line. Now we look for the normal line. So for the normal line, we have y is equal to -1 over 3 as our m, plus c, the constant.
Excuse me, sir.
Okay.
Hello.
Hello.
Yes, can you repeat on the equation? MT Mn is equal to -1. I didn't get you clearly.
The one we are calling mt is a gradient of the tangent. Okay, the one we are calling mt is a gradient of this line. The one we are calling mn is a gradient of the normal line. If you multiply the two gradients, you get -1. So always, when you're asked to find the normal line, use the tangent gradient to get the normal gradient using this relationship here. You get the product is equal to -1. So that you go back because now you're looking for C. So when you're looking for C, remember this guy, the normal line, is not passing through these points for the. It's not passing through these points for the line. It's passing through the middle of these 2 points. So you can get the midpoint. The midpoint is just x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So we'll add x1 is 2, x2 is 4, divided by 2, comma, we'll add y1 is 1, y2 is 7, divided by 2. So the midpoint is going to be 6 over 2, which is 3, 8 over 2, which is 4. So this line passes through 3, 4. So you use 4 for y, 1 over 3 multiplied by 3 for x plus c. So these will cancel. So this one will be taken the other side. It will go as a positive so that we get 5. So you have y is equal to negative 1 over 3x plus 5 as the normal line equation. All right, no problem. Sorry. Saturday. Sabbath. All right, cool. Hello.
Yes. So is it by the equation? Can you safely say that the normal, the equation of the normal and that of the tangent are inverse of each other?
I've never said that it's such a thing. Let's find the inverse of this one. We solve for x. So say y plus 5 is equal to 3x divided by 3 divided by 3. So the inverse, we have y plus 5 over 3. Are you saying that it's not directly true? Because the negative is not there. The 5 is being divided by 3. So that's the situation. So you cannot say that's the inverse. No, it's not the inverse. But the tangents, the gradients, again of the tangent and that of the normal are negative reciprocals of each other. That is what we can say. So this was not what we're going to do today. I mean, this was introduced because we want to work with lines of such nature. No. I introduced this to remind you of how you get the tangent line if you are given 2 points and what we call the normal line, so that we now use calculus to get the tangent and the normal line. That's the purpose of this class today. We go straight into let me give you the how to. So how to find the tangent line. Okay. Okay, there was a network interruption there. So how to find the tangent line equation? Step 1, so say given f of x at x naught comma y naught. So say step 1, find the derivative of f of x. Okay. After I find that derivative, step 2, you substitute x naught for x in f prime of x to obtain the gradient of the line passing through x naught comma y naught. Step 3, use y is equal to mx plus c and x naught comma y naught to find the complete equation of the line. 2, how to find the normal line equation given f of x at x naught comma y naught. Step 1, find the gradient of the normal line using m normal mt is equal to -1. And then step 2, use y is equal to mx plus c and x naught comma y naught to find the complete equation of the line. Here, we only have 2 steps because you have to go through step 1 and 2 for you to get the normal line of the tangent line equation. So you first need to get the gradient of the tangent line, and then that's when you start talking about the normal. That's why I've deliberately said step 1 for normal is to use the mn mt is equal to -1, because you would have found mt in the tangent line equation. So we can understand it this way. Let's have an example. Examples 1.
Excuse me, sir. I'm kind of asking for the previous page. Okay, thank you.
Find the equation of the tangent line to the curve y is equal to x squared plus 2x minus 3 passing through the point um, 1 comma 0. Hence, find the normal line equation to the curve y passing through the point 1 comma 0. Solution. So we follow our steps. We are starting the tangent line to the curve this, and here we said the first step is to find the first derivative. So let's find y prime. The derivative of this is 2x plus 2. And then, after I find the first derivative, you substitute x naught for x in f prime to obtain the gradient of the line passing through x naught comma y naught. Meaning, when you find the first derivative, in the first derivative equation, substitute the point, that one, to find the gradient. So in this, where there is x, let's put 1, we'll get 4. So we are saying the gradient m is 4 for y is equal to mx plus c for the tangent. Okay? That's what the second point is saying. Substitute x naught for x in f prime of x to obtain the gradient of the line passing through x naught comma y naught. Then the third step, use that equation to find the complete equation. Use the equation and the point. Meaning, for you to know c, use the equation, this one, and the point. So, in our equation, we know what m is. It is 4. We know what y is. It is 0. So we'll say 0 is equal to m is 4, x is 1, plus c, telling us that c is equal to -4. So the tangent equation, the tangent line equation is y is equal to 4x minus 4. We are done. For the tangent line, it's very, very easy. For a tangent line, it's very, very easy. You only need to find the first derivative. In the first derivative, substitute the point given. What you obtain is called the gradient of the tangent line. Then use the gradient with the point given to find c. Then have your full equation.
Sir,
Hello.
where did we find the 4?
In the first derivative, after you find the first derivative, go back to the point. After you find the first derivative, go to the point given, because the line you're looking for passes through that point. So get that point and substitute in the first derivative. Where there is x, put that number in the point in the first derivative. The number you get is what you're calling the gradient, this 4 here. That's why we got the 4.
Oh, okay.
Okay. The second part says, hence find the normal line equation to the curve y passing through the point 1, 0, passing through the same point. To find the normal line, we need to find the gradient of the normal line. But we know that the gradient of the tangent multiplied by the gradient of the normal is equal to -1. What does it mean? Since we have the gradient of the tangent, which is 4, multiplied by the gradient of the normal, and we'll get -1. This means that the gradient of the normal is equal to -1/4. So y is equal to mx plus c. This time around, the m is -1/4. X plus c. This normal line also passes through the same point. So we can use it to find c. In the normal line, in the point, y is 0 and x is 1 plus c. This means that c is going to be +1/4. And so the normal line equation is y is equal to -1/4x plus 1 over 4. So we have answered the question fully. Very, very nice. Very, very simple. And it's called the application of calculus. Now, when you're applying calculus in that way, in mathematics, we like applications so much, so that the mathematics is appreciated in medicine, in engineering. So what do? We bring such statements that you also find when you go to other branches. So such things in the exam cannot miss. It will be up to you whether to go for this question or to leave it. Example 2. Find the equation of the normal line the curve f of x is equal to 3x squared plus 5x minus 2 at the point at the point 2 comma or we make it a bit nice, we say when x is equal to 2. So find the equation of the normal line to the curve that when x is equal to 2. So for us to go to the normal, we pass through the tangent. So our solution, first thing is to differentiate f. We'll get 6x plus 5. Second thing is to get this value of x, substitute it in this derivative. 6 multiplied by 2 plus 5, we get 12 plus 5, which is equal to 17. This 17 is called the gradient of the tangent. Gradient of the tangent. Which we know that when this 6 is multiplied by the gradient of the normal, we must get -1. This means that the gradient of the normal is equal to -1 over, this 17, not 6. This 17, when multiplied by the gradient of the normal, we must get -1. meaning that the gradient of the normal is -1/17. Okay, so the equation of the normal is y is equal to mx plus c. So is y is equal to -1/17 x plus c. What does it mean? For us to find c, we need a point x, y with a known value of y. But we only have x. So what do? We can use that x to find y. Because a point is x, y. Meaning, if we get that 2, substitute it in the original function, the value we get will form a full point with x is equal to 2. So f of 2 is 3, 2 squared plus 5, 2 minus 2, which is 3, 4 plus 10 minus 2. That's 12 plus 10 minus 2, which is equal to 20. So we have a point 2, 20. So we use this point now to find c. So when y is 20, x is 2, implying that c is equal to 20 plus 2/17. We can simplify this, 17 down, 20 by 17, we get 0, 4, 3. So we get 340 plus 2, which is going to be 342/17 as our c. So the equation of the normal line is y is equal to -1/17x plus 342/17. If we want, you can write this, you can multiply throughout by 17 and have 17y is equal to -x plus 342. This does not mean that if you don't reach here, then your answer is correct. I said if you want. This is an if situation. This is the solution. So to find the normal line, you need to pass through the tangent. Get the gradient of the tangent first, because it's the one that is directly related to the first derivative. From there, use it to find the gradient of the normal. If you are given just a value of x, use that value in the original function to find the corresponding coordinate, which is the y coordinate, for you to have a full point to use when looking for c. It must be okay.
Sir,
Hello?
sorry, I came in a bit late. So if we're given both x and y coordinates, there's no need to substitute and find y, right?
There's no need to substitute because you already have the point, so you just use them to find c.
Okay, and then how did we find -1/17?
We are multiplying always the gradient of the tangent by the gradient of the normal. Whenever we multiply, we must be getting -1 because the guys relate in this way. They are perpendicular to each other. Where they meet, they form 90. So this relationship is described well by saying their product is -1. So they are negative reciprocals of each other. And that's the reason why we started by finding the gradient of the tangent, even if we're looking for the normal. In some courses, we call this first derivative as the gradient equation. We don't call it the first derivative. We call it the gradient equation. So,
So if the question didn't say find the equation to the normal line, there'd be no need for the normal equation, right?
there's no need. You only get the tangent one.
All right, thank you.
Okay. And in the point x comma y, please note that if you are dealing with a single variable, y will only be used to find c. If in your derivative you have x and y, cases where you have used implicit differentiation, you are going to have to use both x and y, even to get the gradient, which will be our next example. And there was a question.
Oh, yes, sir. I'm kindly asking you to explain again on how we found 17y is equals to negative x plus 243. I didn't really understand.
So since we had 17 as a common denominator for the right-hand side, you can decide to multiply by 17 throughout so that you don't have a fraction in your solution. You can decide to. If you don't want, you leave your solution with fractions. It's still okay.
All right, sir.
Okay.
So,
Yes.
are there cases where you can be given the y coordinate instead of the x coordinate?
Not necessarily.
Okay.
But an exam is an exam. If you find such a situation, you have to use the same y to find x. Okay, another example. This was example 2. Example 3. Find the equation of the tangent and normal lines to the curve x squared plus y squared is equal to 1 at the point at the point 0, 1. Or maybe to avoid the horizontal thing, okay, it's a good exposure at the point 0, 1. Solution. If you are given x squared plus y squared is equal to 1, you can choose, we can choose to differentiate this after solving for y, or we differentiate it using implicit differentiation. Implicit, we said, you differentiate x squared, you get 2x. You differentiate y squared, you get 2y. Using power rule, you get 2y. But because you are looking for dy dx, when you differentiate y, you write dy dx. If you differentiate 1, we get 0. This means dy dx is equal to negative 2x over, so let's say the points 1, 0, 1, so that this one should be for 1 after, because I've seen that we may not have a nice question here. Then the other one, 2, it can't work. That will be crucial. So let's just say the other
Change
one,
the x coordinate.
x is equal to half. To now make sense. Okay, so you first solve for dy dx. So you have taken this the other side, and then you divide 2y, so that the dy dx remains alone. Now in this equation, to find the gradient of the tangent, you go to the point, for 1, you go to the point 0, 1, and get the value x, y. So get both values and substitute them in dy dx to obtain m, which is going to be negative 2, 0 over 2, 1, giving us 0. Now, when the gradient is 0, it means that you have a horizontal line. Okay, so your line is going to be y is equal to c, meaning we'll just have y is equal to 1. C, because even if we put the mx plus c, m is 0, so you have y is equal to 0x plus c, which is just y is equal to c. So at that point, y is equal to 1. So we'll get y is equal to 1. Annie,
Yes, sir. I've got a question on the dy dx. Why is it negative 2x?
now because we are solving for dy dx, which is being multiplied by 2y after you add 2x on the left. On the right, we have 0. So we make dy dx the subject of the formula. Is that enough?
Ito kakasheni angathi machinza cyane the x coordinate such a 0.
So at this very point, the equation of the normal, remember we said mt m normal is equal to negative 1, but mt is 0. So mn is going to be -1/0, which is undefined. Okay. Why? Because a vertical line does not have a gradient. So what do we say? We say no, or in this case, when it's direct, we don't have the normal equation. That is for this point. You may find this situation where your gradient is 0, and then you fail to write anything. Here we are saying when the gradient is 0, you must know that if you're looking for a tangent line, then it's just a horizontal line. Y is equal to c. So pick the constant given in the point for y. And you won't have the normal equation because its gradient will be undefined. For any vertical line, they do not have a gradient. For 2, so that we see what happens. For 2, you get the same derivative, okay, and substitute x. But this derivative will also have y. So you first find a point or the y value corresponding to half in x. So since we have x squared plus y squared is 1, when x is half, what is y? So we'll have y squared is equal to 1 minus 1/4, giving us 3/4. So we have y is plus or minus the root of 3/2. So we are talking about 2 points. Okay. So if we pick one point, let's pick the point root 3/2. We find the gradient of the tangent. So we have m is equal to, in dy dx, we'll substitute the point half, root 3/2. So we'll have -2 half over 2 root 3/2, giving us -1/3 as the gradient of the tangent line at that point. So that you have now y is equal to, when m is -1/3 x, what is c? You go back to the point, when y is root 3/2, you know that x is going to be half plus c. So what is c? C is, we take the other side, so we have root 3/2 plus plus 1/2 root 3. We are looking for c. So 2 root 3 as a common denominator. And then here we'll get 3 plus 1, giving us 4/2 root 3, which is just 2/3. So what is the equation? The equation will be y is equal to -1/3 x plus 2/3. This is the equation of the tangent. line. Hello?
You lost me. You lost me there on the divide the x1 over.
So here we are saying we want to find the m for the tangent. Remember, the m for the tangent is just the first derivative, and then to get a constant, you substitute the point. So we first found the corresponding value of y to x when x is half. We substituted x half in the equation and got 2 points, plus or minus 3 over 2 as y when x is half. Now I have said, let's pick for x is equal to positive root 3 over 2, so that we form a point, and this is a full point. So to get the gradient, we substitute this full point in the first derivative, and the first derivative is here. Okay, this is the first derivative, negative 2x over 2y. So where there is x, you substitute half, which is here. Where there is y, you substitute root 3 over 2, which is here. But this 2 and this 2 cancel, this 2 and this 2 cancel. So we remain with negative 1 over root 3 as our m. This is the gradient now for the tangent line. So you substitute this gradient where there is m in the tangent line equation. Remember, we always have this setup. So where there is m, you substitute. Hello?
So, like on the y values, we have two values, like the positive and the negative. So which one, how can we know that we need to use the positive value?
You need to use both if you find both.
Oh, we have to use the positive one?
You use both of them if you find 2.
Okay.
If you find the 3, you must use all the 3 as points.
But for the
because
gradient,
you're going to have, you use each to get the gradient. Each will have its own gradient, because those will be 2 different lines. Because these points are separated, is it? A curve has so many gradients depending on the point.
oh, thank you, sir.
Okay. So what we call a gradient, this is a circle. And when you say find the gradient at a point, you mean find the equation. I mean, when you say find the equation of a tangent line at a point. So if it is this point, then you're finding for that line. If it is this point, then you're finding for a different line. If it is this point, then you'll be finding for a different line. If it is that point, you'll be finding for a different line. So you can have so many gradients, I mean, so many tangents, depending on the point that you are given. So if you find 2 points, know that I'm dealing with 2 lines. And I must give the equations of those lines. So far we have 1, the tangent. Let's also find its normal. So to get its normal, we now need space. So say the m was negative 1, was negative what? Negative root 3 over 2. Let's be sure. The m was negative 1 over root 3.
3.
1 over root 3. This is the m, at which point? At the point half, comma, root 3 over 2. Now I want to find the mn. This is the mt. So we know that if we multiply the mt by the mn, we'll get -1. But the mt is known, but the mn is -1. So we multiply throughout by -√3, multiply throughout by -√3. So we'll get mn is equal to +√3. This is the gradient of the normal line at that point. So y is equal to mx plus c. So we'll have y is equal to √3x plus c. We now need to find x. So we bring in, when y is √3/2, x is half. So we take this to the other side, we'll have √3/2 minus √3/2 is equal to c, meaning that c is equal to 0. So for this one, we'll have y is equal to √3x, since c is 0. This is the normal line equation.
Excuse me, sir.
Hello.
When you multiply by the negative root, oh, okay, no, sorry, thank you.
Okay. It was in the numerator, is it?
Yes.
So you can't get 3. So it is recommended that you also find the two equations at this point. So we're not going to find, because even if we find, it's the same procedure of solving. The solving is the same. The equations will be different, but we are saying the procedure of solving is the same. So it's better we spend our time learning new techniques and not the method of solving. So we bring in another variety, another way in which we expect questions to be asked. This was example 3. Let's have example 4. Find the equation of the tangent line and normal line to the curve f of x is equal to x squared. This one will be too boring. Just change x squared. I put 4x squared plus 7x minus 2 given that the gradient of the tangent line the gradient of the tangent line is what should we say equal to? Let's just say is 2. Find the equation of the tangent line and normal line to the curve, given that the gradient of the tangent line is 2. Solution. We know that in the first derivative, which is 8x plus 7, when you substitute x, you get the gradient. But we are given that when you find that x, your gradient is going to be 2. If you had that x, if you substituted it in the first derivative, you are supposed to get 2 because 2 is what you get when you substitute that x. This means that 8x plus 7 is equal to 2. So if we take this to the other side, we'll have 8x is equal to 2 minus 7 is minus 5. If you divide by 8, we're going to have x is equal to negative 5 over 8. Okay? This means that we could easily find the equation of the gradient, the equation of the tangent, because if the gradient is already given, it is 2. And we have the value of x, where this line passes through. The only challenge is that we don't have a value of y for us to find c. So what we can do here is to get this value of x, substitute it in f, so that we get the value of y. So we have 4 negative 5 over 8 squared plus 7 negative 5 over 8 minus 2. This is, then we know that 4 can go into 8 twice. So we just say 25 over 2 minus 7 by 5, that's 35 over 8 minus 2. If we take 8 as a common denominator, we'll have 50. Is it 50? No.
So wouldn't that be 4 down there?
When 4 goes into 8, it's going to be 2.
Then after you square it.
After I square it. Oh, it's like we entered. That's very, very dangerous. How did we even manage to enter the squared thing and divide? So when you square 8, we get 64. 64 divided by 4, we get 16. So it's supposed to be 16 here. Very good observation.
It won't be the same if you just divide the 4 into 8 to give you 2, then you square it.
It won't be the same. So
That
to avoid losing anyone, we're saying this is 4, 5 squared is 25, 8 squared is 64, minus 7 times 5 is 35 over 8 minus 2. 4 here 1, 4 here 16. So the common denominator now is 16. 16 in itself we get 1. 8 into 16 we get 2. 2 by 35 we get 70. Minus 1 into 16 we get 16. 16 times 2 we get 32. So we do the addition here. 70 plus 32, that is 102. Minus 25. That's 77. It will be negative 77 over 16. Okay, that is the value of y when x is negative 5 over 8. So you can now come to this equation and find c. Of course, we know y is negative 77 over 16 when x is negative 5 over 8. Then we can find c. We take this to the other side. We're going to have c is equal to negative 77 over 16 plus 5 over 4 is equal to, common denominator again is 16. So we have negative 77. 4 into 16 is 4. 4 by 5 is 20. That is 77 plus 20, we get negative 57 over 16. So we come back and say the equation is going to be y is 2x minus 57 over 16. This is the equation of the tangent line. The logic here is we are given the gradient already. So when you find the first derivative, you don't need to find the gradient. You need to find the value of x that gives you that gradient from the first derivative, since the gradient is given. After having that value of x, for you to find the c, you need the corresponding value of y to that x. So you go in the original function, substitute that x for you to find the y. We are shaking tables today. Nice. You need to stop sleeping now. School is becoming busy. As here we don't sleep.
You
As
stopped
here
a
on
long
campus.
I
time.
think so.
As here on campus we don't sleep.
Sir,
Hello.
there's a nice question here.
Before that nice question, it's really not nice. So this, so we still need
It's
to find
nice,
the
sir.
norm.
Okay, sir.
We still need to find the norm. Now to find the normal, since the tangent gradient is given, the first thing we do is to multiply that 2 by the gradient of the normal so that we get negative 1. This means that the gradient of the normal is going to be negative half. Okay? We already have a point. The point is negative 5 over 8, comma, comma what? Comma negative. I'm looking for the y value that we found. This one
Negative
here.
77 over 16.
Okay, negative 77 over 16. Wonderful. Okay. So this one and this one will help us to find a c, so that we find the normal equation. So y is equal to mx plus c. So what is y? Is negative 77 over 16 is equal to m is negative half, x is negative 5 over 8 plus c. So we have negative 77 over 16 minus 5 over 16 is equal to C. So 16 is the common denominator. Hello?
Can you please go back to the previous slide? Thank you.
All right. So we have negative 77 minus 5 is C. So that C is negative 2 over 16. We can simplify. What goes in there? 2, okay, 2. 2 goes in it, 2 41 times. In 16, 8. Nothing else goes there apart from 1. So that the equation now is y is equal to negative half x minus 41 over 8. This is called the normal line equation. Very, very nice. Okay, so as you are still writing, what the question? Is it David?
Yes, sir.
What was the question?
Sir, it's find the equation of the tangent to the curve x squared plus xy plus y squared is equals to 1 at the point 1 comma 0.
We want the tangent equation, is it?
Yes, sir.
So we want the tangent line equation. So the full point is already given. Ours is just to find the derivative. So let's find the first derivative. We differentiate x squared, we have 2x. To differentiate this one, we use implicit. You first differentiate x, you get 1. 1 times y, you have y. You differentiate y, you get 1. 1 times x, you have x. But because you have differentiated y, you multiply by dy dx. Plus, differentiate y squared, you have 2y, and then you multiply by dy dx is equal to 0. We are looking for m, and we are given a point. So where there is y, we'll take 0. So where there is x, we'll take 1. So we have 2 multiplied by 1 plus 0 plus 1 multiplied by dy dx plus 2 multiplied by 0 dy dx is equal to
So,
0. Hello?
a quick question. Solving like that in an exam, are we supposed to show the steps that we differentiated y there?
No, it's not important.
Oh, okay.
What is important is separating them like that. Then they will know that this guy understands implicit differentiation.
Thank you.
So this is 0. So we'll have dy dx is equal to this guy taken the other side, negative 2. This is the gradient. So you're looking for y is equal to negative 2x plus c. But you're given a full point. Y is 0 when x is 1. So that c is 2. So your equation is y is equal to negative 2x plus 2. Less than a minute, then you take about 15 minutes. So the reason why calculus is easy is because it has methods. And the reason why sets are difficult is because there are no methods in set. You think throughout when you're solving a set question. Find the intersection B and they're given intervals. You keep thinking throughout till you get a solution. But here there are methods. You don't think when there are methods, you just bring the method and start calculating. That's all. So find the first derivative, yes.
Starting for implicit something. How did it happen?
Implicit differentiation. Oh yeah. This is I sent the video today. That if you have time to watch the methods of differentiation, because you are my people, who do a recap in implicit differentiation. If you are given a function x to the power 3 plus y to the power 3 plus 2y squared is equal to 4x. The normal way is if they say find dy dx, the normal way is that we must be able to express y as a function of x so that you can differentiate easily. But looking at this question, it looks like the hardest thing is to solve for y in this question. Very, very difficult. Okay, so what we do is we'll differentiate y wherever it is. And the time we'll be differentiating y, we'll be doing as if we're differentiating x. Meaning, when we're differentiating x, we are free in the same way we've been differentiating using power rule. So we'll say 3x squared, that's all for x to the power 3. Plus, for y, just like we differentiated x to the power 3, we'll differentiate 3y squared. But we're supposed to solve y in terms of x, which you couldn't do. So we'll just say we are differentiating this with respect to x and not with respect to y. Plus, you differentiate 2y squared again, you get 4y. But because it is y, you multiply it by dy dx to indicate that I was supposed to solve for y. But because I'm unable, I've just differentiated it as if it was x, but I know it is not x, it is y. So I'm differentiating y with respect to x. And then differentiate x, you get 4. The question is asking you to find dy dx. So put the dy dx together, factorize what is common. You have dy dx. From here, you remain with 3y squared plus 4y is equal to 4. We take this the other side, minus 3x squared. Because you're looking for dy dx, we'll divide by 3y squared plus 4y. We'll divide by 3y squared plus 4y, so that we get dy dx is equal to 4 minus 3x squared over 3y squared plus 4y. This is an example on implicit 2. Another example, if you had x squared y to the power 3 is equal to 4x plus 1. Another situation, okay? We know here we can solve for y, but it won't be nice to the cube root of some functions. And it will require us to use maybe quotient and chain rule. It will be more work for us. So what do? We use implicit. So on the left, we have a product. So we'll treat it as if it is uv, product rule, where u is x squared, v is y squared. I mean y to the power 3. Then differentiate u, we get 2x. When this x, we just say 2x, we are done. Differentiate v, it is 3y squared. But remember, we are looking for dy dx. So this is y, which must be represented with respect to x. So you multiply by dy dx. So that the derivative of this is going to be u prime v plus v prime u, which is u prime is 2x, v is y to the power 3, plus v prime is 3y squared dy dx, multiplied by u, which is x squared, is equal to the derivative of 4x is 4, of 1 is 0. Now we're looking for dy dx squared, y squared, dy dx is equal to 4. Let's take this to the other side, of minus 2x y to the power 3. So we have dy dx is equal to 4 minus 2x y to the power 3 over 3x squared y squared. So we have found the dy dx using implicit differentiation. So that,
Yes, sir.
hello.
Maybe you can repeat, sir, on 2x y cubed plus 3y squared y dx x squared, how you move the 2x y cubed to the other side. Like,
Okay.
as in the 2x y cubed also has to have y dx.
No?
Why?
Does it have to have 2x y cubed? It doesn't need to have, because we are correcting to form this. So u prime is just 2x, there's no dy dx. V is just y to the power 3. So it's not dy dx. So that's just a product of u prime v plus a product of v prime u plus a product of v prime u, where v prime is the one that has dy dx. U doesn't have, it's just x squared. That's why you're only seeing dy dx appearing only once.
Okay, thank you, sir.
Okay. So because of venues, the physical one is 1 hour. And the venues are so difficult to find because you don't want to see first years learning. So it's 1 hour and 3 times. But the online one, as it is, 2 hours, 4 times. Hello?
Yeah, on the second last stage, I'm confused how, like, I can't see the 2x when those things are moving.
You can't see the 2x.
No.
So we said, since we have x squared being multiplied by y to the power 3, to differentiate this, we use product rule. We assume that we have a product uv, and product rule says the derivative of uv is u prime v plus v prime u, where u prime is a derivative of u and v prime is a derivative of v. So we let u be one of these things that are being multiplied here. So u is x squared, v is y to the power 3. The derivative of u, which is called u prime, is 2x. The derivative of v, which is y to the power 3, is 3y squared, but because we have differentiated y, we multiply it by dy dx. So this is v prime, this is u prime, this is u, and this one is v. Now we collect them to form this derivative here. U prime is 2x, so we have 2x multiplied by v. V is y to the power 3, so we have y to the power 3 plus, which is this plus here. V prime is this one here, which is here, multiplied by u. U is x squared, so we have x squared is equal to, we are done differentiating the left hand side. We go and differentiate the right hand side, which is 4x plus 1. What's the derivative of 4x? Is 4. The derivative of 1 is 0. What are we looking for? We are looking for dy dx. So to find dy dx, we take everything else that is not dy dx the other side. So we have taken this the other side. That's why we have 4 minus 2x y to the power 3, which is this piece here. Then we've remained with 3x squared, this x squared here, multiplied by y squared, this y squared here, because this whole thing is product. So I can rearrange it in any way, multiplied by dy dx. Because I want dy dx, I will divide here by 3x squared, y squared. We'll do the same on the right. We'll divide by 3x squared, y squared. So these will cancel and leave us with dy dx on the left, which is equal to 4 minus 2xy to the power 3 over 3x squared y squared. I hope it's okay now.
Morning, Buga. We sleep. You guys, we don't sleep at home. Special.
Okay, so this one ends here. We continue tomorrow.
Sir,
Following the timetable. Hello.
I'm asking for screens 1, 2, and 3.
You're asking for screens 1 and
2 and 3.
Manatamba video, sister.
Not 3 upper video.
1 is here.
The piso. You have a nice name, Nchirozi.
Thank you. I'm done with 1.
At what?
Thank you.
3.
3. 3 is the most important one.
Have a good night, Sam.
Good night. Thanks. We
Fila,
end.
bonne.
Thank you, sir.
Basiye bakarenga.
Einen